What is a thresholding activation function? Imagine a light switch that turns on only when the room gets bright enough. That's similar to what a thresholding activation function does in a neural network. It's a simple way for a neuron to decide whether to activate or stay inactive based on the input it receives. In artificial neural networks, each neuron gets multiple inputs that are weighted and summed up. The thresholding activation function then checks if this total exceeds a certain set value, called the threshold. If it does, the neuron fires and produces an output, often a fixed number like 1. If it doesn't, the neuron remains silent, giving an output of 0 or inactive. This mimics how biological neurons work, which fire only when the combined signals reach a specific level. The main idea is that the thresholding function acts like a binary switch. It either activates the neuron or not, based on whether the input crosses that threshold. Because of this, it's sometimes called a binary step function or a step activation function. It's very straightforward and easy to compute, which makes it useful in simple models or early neural network designs. But there's a catch. Since it only produces 2 outputs, it doesn't give information about how much the input exceeds the threshold. This makes it difficult for the network to learn complex patterns using gradient-based methods like backpropagation. In modern deep learning, more advanced activation functions like ReLU or Sigmoid are preferred because they provide smooth, differentiable outputs. These functions help neural networks learn better and faster by giving more detailed feedback during training. Still, understanding thresholding activation functions is important because they form the foundation of how neurons decide to activate. They help explain the basic decision-making process in neural networks and how simple rules can mimic biological behavior. So, in essence, a thresholding activation function is a simple rule that turns a neuron on or off depending on whether the input is above or below a certain point. It's like a gate that opens only when enough input signals come through. This concept is fundamental in understanding how neural networks process information and make decisions, even in their simplest forms.